Hello! Welcome to today's lesson on circuit diagrams and the main components of a circuit. Today we will cover what circuit diagrams are and why they are useful before we move on to examine the main components of an electrical circuit and look at some examples of circuits. This is the first lesson in the electricity unit. You should already be familiar with the concept of energy from our previous unit, since it will be very helpful as we move forward. Let's delve into our lesson on circuit diagrams and understanding the main components of a circuit. A circuit diagram is a simplified representation of an electrical circuit. Instead of showing an actual physical setup with wires and components, we use symbols to represent electrical components. This makes it much easier to visualize and understand the circuit's design and function. Circuit diagrams are invaluable tools in both designing new circuits and troubleshooting existing ones. Not having to deal with the potentially complex and messy physical setups helps us focus purely on how the circuit operates. In circuit diagrams, various symbols are used to represent different components. Here are a few key examples. A battery is symbolized by a couple of lines where one line is longer than the other. A wire is denoted by a simple line connecting the different symbols. A switch is shown as a break in the line with a small line extending at an angle. A large angle represents an open switch, while a small one represents a closed switch. A lamp or light bulb is represented by a circle with a cross inside it. These standardized symbols enable clear communication about circuits between engineers, electricians, and anyone studying electronics. For any functioning circuit, there are generally three main components that must be present. An energy source. An energy source is what powers the circuit. Common examples include batteries and power supplies. Without an energy source, there would be no electric current flowing through the circuit. Electrical components. Electrical components are the parts that perform specific tasks within the circuit. Examples include resistors, diodes, and lamps. Each component has its functions such as converting electrical energy into light, heat, or sound, amongst other forms. In later lessons, we will learn about many essential electrical components in detail. Finally, a complete circuit must have a closed path for the current to flow through. This path is typically made up of wires which conduct electricity. If there is any break in the path, which we refer to as an open circuit, electricity cannot flow, and the circuit will not work. Let's look at a simplified circuit diagram for a flashlight as an example. First, let's look at its energy source. The flashlight uses a cell, battery, as the energy source. In the diagram, this is shown by the battery symbol. Now we will look at the electrical components. The electrical component here is the lamp, which is symbolized as a circle with a cross. We also have a switch to turn the circuit on and off. Finally, we can look at the closed path. Wires, represented as lines, connect the battery, switch, and lamp in a loop. When the switch is closed, the circuit is closed. When the switch is open, there is a gap in the circuit that prevents the flow of current. As a result, the lamp does not light up. When you close the switch, you create a closed path for electricity to flow from the battery through the wires and into the lamp. The closed circuit allows electricity to power the lamp, causing it to emit light. In coming lessons, we will delve deeper into specific components and their symbols as well as their uses. In today's lesson, we explored circuit diagrams and their importance in representing electrical circuits in a clear and standardized way. We discussed how circuit diagrams use specific symbols to represent different components, making it easier to understand and troubleshoot circuits. We also covered the main components of a circuit and examined an example circuit to see how symbols come together to illustrate a complete electrical pathway.